Hello and welcome back to Metacode. So today we are making a weather app in Python. So that's really exciting. It's the most advanced project that I've done on this channel so far. And basically what we're going to be doing is we're going to be using an API. It's the first time I've ever done tapping into APIs on this channel. And basically we are going to be using this API called OpenWeatherMap, which is going to give us the weather for our project. So basically what an API is, and it stands for Application Programming Interface. And basically it's basically a database of information in which we are going to ask it or request it for some information, whether it be the temperature or something, and it will return it to us. And with OpenWeatherMap's permission, we will use that data in our project. And in this case, all we're going to be doing is returning that information to the user. Okay, so let's just get right into it. So first thing you're going to have to do is sign up for OpenWeatherMap. So you can go to openweathermap.org. I will leave a link to it in the description. You go to sign in and click create an account. And you can create an account, set up an email, sign up. I've already have an account in this, so I'm not going to do that. But it will send you an email with an API key. Whatever you do, do not send that API key to anybody. Like no one at all. That is for you and for you only. And you're going to need it to ask the API for information later. But that's that for now, and let's get on to the coding. Okay, so here we go. And before we get on to it, I just want to let you guys know that OpenWeatherMap actually can provide you with information in 3 different types of temperatures. Imperial, which is what we use in the US. I'm in the US, by the way, right now. Which is, feet, yards, miles, pounds, stuff like that. And then there's the metric system, which is what most of the world uses, Celsius, stuff like that. And then there's SI units, which is Kelvin, which you might know is used for temperature, and basically no one uses that. So that's only used for scientific stuff, and that's actually the default. But what we're going to be using today is the metric system, because that's what most people use. All you have to do is change the word metric to imperial in the API request, which is what we use, obviously, to get our data. So if you want to do that, you can do that. And so we're going to need 2 libraries for this project today, and so let's import them. So anyway, we're going to write import datetime, which we're going to be using for the sunset and sunrise time. And then next thing is we are going to import requests. Now you might not have requests installed, so you have to go to your terminal here, which you can open, and write pip install requests. Hit enter. For me, it's going to say requirement already satisfied, which it does right here. But that's because I already have it installed. If you don't, it will install it for you. And here we're going to write from requests import get. And that is that. Perfect. So the first thing we're going to have to do is obviously ask the user where they want to get the weather for. So they might say, I want to get the weather for London, something like that. So say place, we can call this variable, and then equals input, enter location for weather. I'm just going to keep it simple for now. And there you go. Next thing you're going to do is, let's just get right into making the API request. So let's just say URL, call it URL equals, and we're going to need a string for this. And let's say HTTP, and by the way, if you don't know how to make an API request, it's not going to be the same for every API. It will be on their website. But for OpenWeatherMap API, this is how you're going to make it. It's api.openweathermap.org. Oh, OpenWeatherMap, sorry about that. OpenWeatherMap.org /data /2.5. Sorry, I have this open on another tab. I'm just making sure I don't get this wrong. /weather. And then Q equals, question Q equals. And the Q equals is going to be the place. So this is very important. We're going to plus place plus, and then there's still more. App ID equals, and app ID and then our API key. So I'm going to blur this out because I don't want you guys to see my API key. Sorry about that, but you know, API keys are kind of confidential, and because sometimes they cost money if you make too many requests. Like if you make a lot of requests with OpenWeatherMap, it will charge you money. But you probably won't do this for basic projects. I think you have up to 1 million calls a month, which means you will have to run this project 1 million times before it will charge you. So here I'm going to blur it, and let's just keep going. So next thing we are going to do is get the data. So we can say data equals get, which is from our request, and then we're going to use our URL. So get is basically used for getting information from APIs, and then we can say .json. And JSON is a kind of a type of a data type, and it's going to return it in a JSON type. So now let's print data, because you might be confused as to what data is. So here, let's print data. And you will be startled at how much OpenWeatherMap really provides us with, because it's a lot of info. Enter a location. I'll just do London for now. Look at this. I mean, this is a ton of data. We have the coordinates for London, the weather, which is going to be, it's fog, description, it's fog. We have the temperature, which is, oh, this is in Kelvin, by the way. Like I said, Kelvin is the default, but we can change that actually by writing and units equals metric. Oops, sorry. No spaces. Obviously, it's a link. And units equals metric. And by putting that at the end, that will make it into metric. So actually, let me just run this again. I'll just do London again. And here we have, let's look at our temperature. It's 1 degree Celsius. Feels like -1 degree Celsius. It is December, so it's pretty cold. But we even have like air pressure, humidity, high temperature, low temperature. We have the visibility. And by the way, on the website, it just says 400 and stuff like that. But on the website, it tells you which units it's using. So like humidity 93 is actually 93%. So that's a lot of humidity. But it is foggy, like they said. So seems about right. We even have the sunset time, which we're going to be using our datetime library. And here it says a bunch of random numbers, which you may not understand right now, but we will use the datetime library to convert that to an actual time that us humans will understand. So that's that. Next thing is let's get some data and save it in some variables. So I'm going to delete this print statement of data. And let's just get the temperature. So I'm just going to name the variable temp equals. And let's look, where can we find the temperature? So let's look at our data here, and we see, where's the temperature? Oh, we got temp equals 1.87. Now, the problem with this is we need to figure out where is temp. Well, temp is inside some other bracket, and those bracket is called main. So we need to get this by doing main and then temperature, because temperature is kind of nested inside of main. But if we wanted to get base, for example, that's not inside any other brackets. So we can just write base. But for this, since temp is inside the brackets of main, we are going to have to do main first. If you don't understand what that means, you will understand it later. So we need to do data, temp equals data, because that's the name of our variable, and then 2 brackets. It's basically an array. So we're going to do main, and then, sorry, we're going to need quotes here, by the way, main, and then another bracket, temp. And that's literally it. So let's print temp. And let's also print data, by the way, because we need to keep the data here so we can look for other stuff too. Enter location. Let's do Tokyo this time. And the temperature is 6.24 degrees. And let's make sure that matches. We look here, temp, 6.24. And this is Celsius, by the way, because we made units metric. If you want to make it like US, you can say imperial. right here, and let's run it again. And let's do Tokyo again. It is 43 degrees Fahrenheit, but I'm going to keep it at metric. I don't know why, I just like metric. Okay, so that is that. Now, we can basically just do a bunch of other variables just like this. So I'm just going to do a few more examples, and then I guess I'll just time-lapse the rest of it because it's basically just repetitive. But let's just keep looking for stuff. We already did one from main section. Why don't we do something inside of wind? Let's get the wind speed. So let's do wind underscore speed equals data again, because that's our kind of JSON thing. And then where is wind speed? Well, it's inside something called wind, and then we see speed. So we have to do data wind and then speed. Speed. And another thing I'm going to show you is, how about let's also do the country. So country equals data and then sys, because we see that here we have our country, Japan, and we go back here and we see that it's inside something called sys. So we can say data sys and then country. And let's print these. So print wind speed and print country. And now let's see what happens. Why don't we do Mumbai? We're in India, which is good. It is 2.63, which is, I believe, meters per second. You can check the website for more information on that. And it is 25 degrees Celsius, which is pretty hot for December. But that's that. So we can keep these actually, and I'm just going to basically go through a time lapse of me doing this. So here we go. Okay, so sorry about that, guys. Turns out I had accidentally stopped recording through OBS, so I couldn't do a time lapse there. I think I'm just gonna cut the time lapse out. And so I put a bunch of new stuff in here. The high temperature, low temperature, what it feels like, the humidity, and the description. Now, the way I got the description is you might see that there's a 0 in the middle here. And the reason for this is when we look at the weather, it's inside, you see 2 brackets. So there's a bigger array for some reason, and we know that in arrays we access stuff based off their index, which is, in this case, there's only one element in this array because it ends where the other curly bracket ends. So basically we just put a 0 there, so we can do weather, 0, and then description. And so I'm just going to print all of this stuff out. I probably shouldn't have deleted that, but okay. Print high, print low, print feels like, print humidity, print description. And that's good enough for me. And I think that's enough data for now. You can do this with however much you want. Now that you know how this works, you can just print out data and look through the data and figure out how to get this kind of stuff. So enter location for weather. Why not San Jose? And we are in the US. We got 11.27 here. First thing is temperature, so 11.27 Celsius, 2.16 meters per second, I believe. I still haven't checked that. 12.22 is the high, 10 is the low temperature. Feels like 9.32. there's haze, and it's 81% humidity. Okay. Haze, that's pretty high humidity. Okay, so that is that. So now that we've got that, it's time for the final thing, which is converting these sunrise and sunset random jumble of numbers, which is right here, into actual stuff, so actual time. So we can convert this into, say, whatever time it is. I believe right now in San Jose it is 12:06 p.m. Or yeah, just 12:06 p.m. So 6 minutes after noon. So the way we're going to do this is let's just create two variables. Let's call it sunrise and sunset. I'm going to actually separate these. Get some organization in here. Sunrise equals, and then what we can do is, why not do, we're going to have to use the datetime library, so we're going to use datetime dot, and then what we're going to do is we're going to say from timestamp, because what these are basically timestamps. This represents a time, so it's called a timestamp. So datetime.from timestamp, and then we're going to say data. We need to access the sunrise still, so data, and we see that sunrise is within something called sys, same thing as the country, so sys, sys, and then sunrise, and that's that, and then basically data sys sunrise, and then we're going to have to convert this to a f string, so a dot strf and then time, and then we are going to write in here %h comma %h and then colon %m and then colon %s. And you might be confused as to what this is. So basically, we are creating a variable called sunrise. We're setting it to this datetime library, and we're converting it by using a timestamp, which is this. This is the timestamp. And data sys sunrise, which is this timestamp right here. And we're going to convert this to a f string, which is basically just a string. And we have %h, %m, %s, where %h represents hours, then we're going to put a colon in the middle, then %m, then a colon, and then %s, which is the seconds. And that is that. So we can just basically do the same thing for the sunset. And let's get rid of equals datetime dot from timestamp, and then data, and then sys again, and then we need to change this to sunset, and then the same thing, strf time, and then %h, %m, %s. And that is that. So now let's print the sunrise and print sunset. And that's that. Now let's print it. Enter location for the weather. By the way, this will return military time. So yeah. Let's do Tokyo. Actually, I like San Jose. Let's do San Jose again. And, 10, it says 1949-49, and here we have, you see here, right here, I put an ampersand by accident. That's why there's an and sign in the middle. So let's get rid of that. Let's run it again. San Jose. San Jose. And it is currently, sunrise was at 10:08, and sunset will be at 19:49, which is 7:49 p.m. That's really late. That's nice in San Jose for December. And so that is that. That means it is working. And there's one last thing that I want to do. Okay, so the final thing we have to do now is just make it so that it's not just units equals metric like we have here in our request. We should let the user have whatever type of data that they want. So we can just easily do this by, first let's create an input. So type of data equals input. Enter type of data. And then in parentheses we can write imperial, comma standard, comma metric. And these are the three types. We can click colon and space just so the user knows they have to type it there. And right here where it says units equals metric, let's hit enter. I'm just going to hit enter because I don't want the line to be too long. And so we're just going to change this units equals metric to right here where it says units equals. We're going to end the quote, and then we're going to hit plus, and then our type of data, and that's it, I believe. That should be good. So let's see what happens now when we hit run. So we're going to hit Mumbai. Let's just type in Mumbai for location. Let's do imperial. And we see here it's not in standard or metric. It's actually in Fahrenheit because it says 75 degrees, which seems Fahrenheit. I mean, if it was 75 degrees Celsius, I would be seriously worried. So there you go. That's that. Everything is working. And so that's it for today's video. If it did work, please be sure to drop a like. If you have any questions, leave them in the comments down below. And so that's going to be it. And I'll see you guys in the next one. And until next time, peace.